in the chat. You can post on the chat. I'll try to keep the chat window open if anybody has any questions there. All right. Let's get started. For this first section, we're going to talk about testing, and we're going to talk about the need for testing and the different types of testing, different approaches, and we'll also review some of the terminology used in testing. First question is why. It always helps as a developer to ask the whys, right? Because you're investing your time, your energy, your capacity into doing something, and it always helps to ask, why would I invest the effort? Why would I invest my time? Why should our organization invest our attention to this technology or this practice? I will say that for sure, in most software development projects, testing is highly underappreciated part of the software development lifecycle because it's time consuming. It takes a lot of our time and the effects aren't immediately noticeable. If you have a functional feature, you write a test, that feature is still the same as it was 10 minutes ago, right? So it's not immediately noticeable. It takes a lot of time. But I will say that having a robust testing process in place does help with quality control of our code and prevent what we call regressions. Regressions are when you develop new features in your application and those new feature introduces bugs on existing features, which are very common. So having some sort of guardrails in your application helps enforce some sort of quality control. I'm going to paint out the scenario on how it starts. I've been through a number of software development projects over the past decade, and I'll tell you how these conversations typically start when it relates to opinions of testing or how people approach testing. And I'll tell you how it usually ends from my personal experience. So if you're working in a team, you might run across these conversations and people might start to kind of voice these opinions. How it typically starts is you're working on a project and the engineers or the product manager says, we need to focus on the feature build where, we have this milestone, we have this timeline, we have to hit this target. As long as it works per what our stakeholders expect, that's fine enough. We'll push the test to a later sprint. Another thought you might hear is it's a simple feature. It's really straightforward. I personally tested it. That should be enough. Another comment you might hear is let's have QA engineers do the test, right? That's why we hire quality assurance engineers so they can do the QA. We're the feature engineers. We build the features. Let's have a dedicated engineer just write the test for it. And another opinion may be if we only conduct UI tests, user interface tests, that should be really enough. That should test for most of the application functionality. And let's talk about how it usually ends with each one of these comments. With the first one, if you prioritize building features and pushing tests to a later sprint, you're not going to get out of that mentality. And it'll be every sprint, every week that you deprioritize tests, it's going to be increasingly harder to catch up because you're just going to have more of a surface area to cover. And it's a mental shift. Everybody on the team, if they always prioritize features and test secondary, it will be very hard. It will be increasingly harder to make that trade-off to say, okay, this is the sprint where we prioritize tests. So with simple features, what happens is the feature itself may be simple and you may test it and it'll work. The issue isn't with that feature in that point in time, but with new updates to the application that might cause a bug in your simple feature. So whenever regressions are introduced, that can be very costly because you're breaking existing functionality that can be simple at that point in time, but it can be a side effect of somebody maybe writing a core service that introduced some sort of refactoring. And then the tossing it off to the QA engineers. What I typically see is that QA engineers are incredibly overwhelmed with work and are understaffed. If you have a backend team of 3 engineers, a front-end team of 3 engineers, and a QA team of, let's say, two to three engineers, the ratio of your core development team and your QA engineers is typically outnumbered. the QA team. So I've seen time and time again, the QA team just been overwhelmed with testing work because they need to do manual testing thoroughly and they need to write automation tests across a very large product. So typically, whenever you can, in your as quality solid engineers, you would want to write some level of tests and not delegate the entirety of testing to QA team. And then in terms of UI tests, what happens is that, yes, you do get the most bang for your buck in UI tests because you're testing the user interface. This is ultimately what the end user sees. However, if a UI test fails, the problem, the actual bug can be anywhere in the stack, right? It's very hard to trace if it's a database issue, if it's a backend issue, if it's a networking issue, if it's a front end issue. And even when it's in the front end, there's many different layers. Is it a state management issue? So having an end-to-end test does cover the application, but it's very hard to troubleshoot and know where the issue is if all you know is at the end of the scenario, at the end of the funnel, something is wrong. So that's usually how it ends when we write. I have experience writing UI tests. My team has written UI tests. And when this fails, it's hard to know, to pinpoint, to be the detective and to pinpoint where exactly it went wrong. And it can actually end up costing the team a lot more time. So having excuses or having some sort of rationale behind delaying software testing, either throwing it to the QA team, putting it into a separate sprint, doing the least amount of effort for testing, ultimately leads to buggy software and a slower speed to market. You're saving a lot of time upfront, but you're costing more potential mistakes downstream. So hope these few points resonate with the people here. And I've heard these comments through and through again, and usually it honestly does not end well for the product build. As the product becomes more complex, we really dig ourselves in a hole by not prioritizing tests. So hopefully that gives us a good context for why it is important and for everybody here to focus in on. But just by participating in the session, it's clear that people have an interest or do think that testing is important. All right, so let's talk about some of the methodology behind testing. When you write a test, it's really a three-step operation. The first part is just setting the environment, setting the context ready. If you're writing unit tests, it may be configuring, making sure you create your objects correctly, your dependencies correctly. If you're writing UI tests, it may be going to a specific screen. So step number one is just getting the background ready for testing. Step number two is performing a single operation. What is the actual functionality you want to test? And that is defined by the operation. An operation can be calling a method on an object. It could be clicking a button. It could be swiping a screen, rotating a device. That could be the actual operation you test against. And number three is what we typically do is assertions. And an assertion is a test against what has actually happened to what should happen. If the expected result and the actual result are the same, then that's great. That means that the operation is performing the way you intended to. If the expected result is not the actual result, then there's something wrong with the test. It may be the test itself, or it may be the functionality is not working. So when we think about the testing process, it's really broken down into three steps. One is setting the context, making sure that you're in a state that you're ready to test. Step number two is actually doing the action. And step number three is validating the results to see if it's what you expect. Whether you do very complex UI tests or very simple unit tests, the same three principles of this methodology is consistent. Now, in traditional software development, and when I say traditional, I mean maybe a decade or two or a few decades ago, typically engineers in the past have written the code, then write the test for the code, right? And typically what happens is that they write the code and they don't have time to write the test. So the test never makes its way into the build. With test-driven development, we flip that order. Instead of writing the code first and then the test, we write the test first and then we write the code. By using a test-driven development, it's a technique that is subtle because you're putting the test first and not at the end. But what you have is you ensure test coverage throughout your entire application. So in a test-driven development process, you write the tests for a feature that doesn't exist, which means that the test will fail because the feature doesn't exist. Then you would build the feature, and you would build the feature to match the tests that you're testing against. And after the feature is built, once you execute the test, and if it passes, then you're good to go. Let me just make sure. I think I hear a little bit of a background noise. If everybody can mute, maybe, unless there's a question. Yeah, that would be helpful. I think we're good. Cool. And feel free to ask questions along the way. So test-driven development is a very popular methodology when it comes to building software with quality guardrails. Now let's talk about, yeah, go for it. Go for it.
Do you think test-driven development is like always worth doing, or like only in specific cases, like for like really, really large projects or something?
That's a really good question. I think there's a proper answer, and the proper answer is you should always strive to write quality code. But then there's a case-by-case basis where it's more of an art than a science. So for example, if you're building a personal project just to learn Nest.js and React, then you probably don't need to do test-driven development. That's not the goal of you committing that time. Is probably to build a small proof of concept. If you're doing some sort of research, some small proof of concept, you probably don't need test-driven development. But I would say if you're building anything production level that is facing real users, then you should definitely prioritize putting tests in the forefront. And nowadays the applications we build are a lot more serious, right? So for example, building autonomous vehicles, building financial systems, these can have real world consequences on the lives of people. And not having these proper guardrails on production systems can really mess things up in the real world. So I would say, depending on the impact of your project, would be you should consider test-driven or not test-driven. If it's a small POC, if it's a side project for learning purposes or educational purposes, then probably not. But if it's for a production system that's going to impact a lot of people, then you should definitely put in the quality guardrails. Yeah.
Got it. Thank you.
Yeah. All right. Great question. Now let's talk about the different types of tests right here. At a high level, you can categorize all these different types of tests into 3 different tests. And there are UI tests, integration tests, and unit tests. And then here's a pyramid, and we can go back to this pyramid, but this is a pyramid by the Google team when they try to draft out their recommendation for what kind of tests you should have in your application. If you go higher up in this pyramid, what this means is that the higher up you are in this chart, the more time it takes for you to write the test and the more time it takes for you to execute the test. So that's what execution time, fidelity, maintenance, debugging. UI tests are the most high maintenance tests. It requires the most of your time, and it also takes a while for it to execute. Specific for mobile for sure, because you have to spin up the simulator, but even like for web, you can have a more efficient approach with headless browsers. But in general, unit tests are the fastest to write, and they are the fastest to execute because you're not spinning up any sort of like browser, for example. And we'll talk about the number of tests in the subsequent slide. But let's dive into each one of them. So with a unit test, you're focusing on a specific unit and a specific object. And that object in testing terminology is called system under test. With a unit test, you're testing purely the code inside that class that you write. And you would assume that any sort of dependencies that class file that you create is working appropriately. So in unit tests, you do not test for any of the dependencies of that class. You test specifically for that class's implementation. And we're going to explore a framework for unit testing using Jest. The pros of unit tests is that it's the fastest to write, it's the least expensive to execute, very straightforward to execute it. However, the con is that because you're very isolated in your testing, you may not have an idea over the bigger picture because you're testing that piece in isolation. With integration tests, we focus on testing how objects interact with each other and if their actual result is the expected result. So this is the part where you actually do include dependencies and you call methods that call dependencies, and you test if the actual result is the expected result. With integration tests, there are typically no user interface involved. These can be two classes, objects calling each other, or if we're doing backend development, these can be two services making API calls to each other. And at this point, you're testing the interaction between two or more objects. These tests are more complex to write because there's just more to consider and they're more time consuming. That's one of the cons of integration tests. And finally, we have UI tests, which test the actual user interface. And you would emulate the behavior of the user as if they were using your application. So you would emulate clicking and scrolling and entering into an input text field. There are web frameworks like Playwright or Puppeteer that allows us, or Selenium that allows us to do automation on the front end using UI testing. And depending on what domain you're operating in, if there's Android, there's the Espresso test framework. If you're doing iOS, native iOS, there's a test kit. So every domain has a different suite of tools for you to run UI tests on. The benefits of UI tests is you definitely get the end-to-end functionality of an application, right? All the way from the back end to the end user. So you're testing for the end-to-end experience. The con of UI tests is that it is definitely the slowest to write and the most expensive to execute. Because you do need to spin up tooling to get that up and running. With web, it can be a little bit different with headless browsers, but definitely in mobile, you have to spin up emulators and simulators to run it. So this is a cookie cutter approach. This is a very broad stroke rule of thumb for how to approach testing in a project as recommended by Google. And it can be different on a case-by-case basis. But one approach to overall testing, when you think about a testing strategy, is if you have 100% of capacity, then the recommendation is to spend, if you have 100% capacity on testing, then the recommendation is to spend 10% on UI tests, 20% on integration tests, 70% on unit tests. And the idea here is that you can write these relatively fast. So it doesn't cost you a lot to write a ton of them to get good coverage over the business logic of your application. And for the very core flows of your application, the very important flows, you would delegate and focus your time on UI and integration tests. So having this testing strategy, what we get is a good test coverage across our code base. And we prioritize UI and integration tests for our very core experiences or key user journeys. So for example, if we're building an app, we should probably have UI tests on sign in and sign out, right? Because if your app can't support sign in and sign out, then the user is not going to go very far. That would be prioritized and it can be marked as a core user journey, just sign in and sign out. Now, there's two different ways to test an application. There's manual and automated testing. With manual, is a person literally sitting on the screen and clicking buttons and executing the test. There's automated tests, which is you writing the code to automate the execution, to perform assertions, and to verify results. There's pros and cons on either of them. With manual testing, the pro is that it's easy to get started. If you're willing, you can just open up a browser, click buttons, and that's, it's very easy to get started. It's very low upfront costs in terms of time. One of the key advantages of manual testing is human oversight and observations. If we come into an application and we might not know all the bugs that are present, but to have somebody go in with a manual review, they might see things that other people might not see. They might catch things that a computer does not catch. So having some sort of manual testing, some sort of qualitative testing can help explore possible errors that are hard to uncover by a computer. At the same time, the human is also prone to error. So that same person we might give him a gold star, him or her a gold star because they found the error that nobody else caught. But at the same time, they might report an error that is just what we call a user error. It's just them not knowing how to use the application. So that same human, while there is some benefits in human oversight, it can also be a hindrance because it can be prone to human error. Manual testing is also difficult to sustain because you can only have so many humans and your application is going to typically become more complex. You're going to throw more features in. So it's going to be hard to have more people cover more features through manual testing. With automated testing, the benefits of automated testing is that automated tests are usually integrated with continuous integration, continuous delivery pipelines. That means you can just push your code to GitHub and you can automatically execute these tests while you take a break and just like eat lunch or something like that. It's easier to achieve high code coverage with automated testing. There's a lot of tools out there like Browser Stack. Even cloud providers like AWS offers a lot of different, I think it's called Device Farm, that allows you to run one test in different contexts, in different browsers, in different operating systems. So it's very easy to write a solid test and have it execute across multiple environments with a lot of the tooling that is present nowadays. Automated tests are reliable because you can always count on the computer to do the same thing over and over again, as opposed to a human who may be very tired that day, didn't have his coffee, and he may just like fat fingered or forget to run a manual test validation. So computers are always reliable. You can always rely on them to execute the same set of instructions. And computers are very fast when it comes to executing tests. They can execute a test in a fraction of a second. And for us, the older we get, the slower we type on the keyboard. The cost of automated testing is that there's a significantly higher upfront cost in both your time and effort. Writing tests requires time. Setting up CI/CD infrastructure requires time. Subscribing to the tooling like AWS Device Farm or Browser Stack requires time and also money. You're paying them to give you that service. So there's a lot of upfront costs, and there's no human oversight or observation. If there's something blatantly wrong with your application, but you're writing a specific unit test for this class, the computer is not going to tell you that there's anything outside of its test that is wrong. It would execute exactly the way you tell it to and validate exactly what you instruct it to. Now, when it comes to, should we do manual or automated testing? How should we approach it? What I've seen in my personal experience is that most organizations heavily skew towards manual testing because they're trying to save costs in the upfront by not subscribing to Device Farm or paying a licensing fee, by not having more engineering capacity, write automated tests. I do think it is healthy to have a balance of manual and automated testing. Why not use each one of these approaches for what they're really good at? You can use manual testing for complex workflows that are hard to code around and can benefit from human oversight. So a simple test can be just a person scanning through the newsfeed for layout issues, right? And then you can use automated tests for simple tests that are critical and that require repetitive workflows. So the user sign up, you're going to sign in the same set of screens to register a user. It's going to be first name, last name, email, password. You don't need a manual tester to go through that flow every single time. So it is healthy to understand what are the pros and cons of these approach and to have a mixture of them where it's most appropriate. All right, so that is an overview of testing. Any questions on testing? I think we've covered a lot of ground already, but I just wanted to set the context on the testing methodology, different types of testing, why it's important before we dive into the details of Jest. Any questions? All right. Now let's go into part 2 of this, which is the meat here, and it is Jest. For the next set of slides, we're going to talk about, an introduction to Jest. We're going to talk about how to properly set up tests and organize them appropriately. I forgot the LY there, sorry about that. We're gonna understand how to use matchers in the context of Jest and how to also mock our dependencies. Jest is a JavaScript testing framework. And what's nice about Jest is that because it is JavaScript based, it actually works in a lot of different domains. So if you're a backend engineer, if you're a front-end engineer, you can equally use the Jest testing framework, which is really great. And even if you're in the front-end side, it doesn't matter if you're using React, Angular, or Vue, or any sort of web frameworks, you can still use Jest. So it's highly flexible. Just taking a look at the numbers, last month, I took this from their website as is. Last month, they have over 20 million downloads. They are used on over 1 million public repositories on GitHub, and they're used extensively at the top tech companies like Facebook, Twitter, New York Times, Spotify. There's plenty more, but I just got tired of typing, but you can find in their official website. They have a lot more. All right, so hopefully it's, Jest is important and is used by everybody. Let's get into how we actually use Jest. Now, the first step we're going to take into is just organization and setup. How do you organize your tests in Jest? Actually, before that, let's talk about installation. Jest is a node package, and just like any other node package, you can just install them with your favorite JavaScript package managers. There's Yarn, there's npm. I'm not super highly opinionated about them. I think at one point Yarn was like pretty nice, and then npm kind of copied Yarn, and now they're kind of the same in my perspective. Maybe somebody here can point out like the nuances between them. But whether you want to use Yarn or npm, I don't think there's a huge debate here. This is how you install them. Let me go to my command line here. So I have this demo project, and I think I'll work alongside the slides. What I'm going to do is I'll create an npm project. And then let me just install Jest. Do npm install save dev Jest. All right, so this is going to be the demo that I'm going to do alongside the slides. And while we're at it, I'm going to create a folder called source for my application source code. Let me just create a class here called calculator.service.js. I'm just going to use JavaScript right here. And I'm going to create a very simple calculator class. And the whole purpose in life for this calculator is to add and to subtract. So let's add 2 numbers and subtract 2 numbers. Why I'm doing this is I want something to actually test against. So I'm just writing a class that can add and subtract. And I'll just export this. So we have something we can test against. And I've installed Jest as a dev dependency. Looks good. This is just demo 2 because I did just demo 1 yesterday. And I have a backup demo. If this burns and crash, I can pull up just demo 1, FYI. All right. For Jest, one of the key methods is describe. And describes allows us to organize 1 or more related tests. That's really it. Don't overthink it. It's just a method for us to organize our tests. And anytime you write a new test suite, a set of tests, you would wrap it in a describe function. And this describe function takes 2 arguments. The first one is just a string for you to describe the test suite. And again, a test suite is a terminology we use for multiple tests that are related to the same thing. So for example, onboarding can be a test suite, login can be a test, sign up can be a test in that onboarding test suite. The second argument that this describe function takes is another function for wrapping the tests. this is what the describe block looks like. So we have a describe function, put in whatever you want as long as it's descriptive. And the second parameter is a JavaScript fat arrow function to contain test stuff. Inside the describe callback method, we have a test function to describe an actual test. So in here, we have a test and we describe what the test is doing. And we have a callback function again, and this would encapsulate the actual test. So describe is a test suite. It contains one or more tests, and every test is defined by this test function in Jest. We can do some setup work. Sometimes we may want to execute something before any of the tests is executed. In that case, we can use the before all function that is provided by Jest. Again, a lot of these Jest functions accept callback functions for you to write your piece of JavaScript code to execute. And in line with more modern JavaScript syntax, we have this fat arrow function. I think you can also get away with just function. That's fine too. So the before all function is executed once before any of the tests is ran. If you want to execute something before each of the tests is run, then you can use the before each method. So typically this is setting up. Remember, testing is a three-step process. The first step is making sure that the context is ready, the background is ready. So before all and before each are useful methods for getting that context ready. And then there's teardown. After you've executed a test, maybe you want to clean up after yourselves and remove some resources, clean up some resources. So we have the after all for after all the texts are executed, execute this function. And we also have after each for after each test is executed, execute the function that's provided after each. So here's an example of just grouping tests in a test suite. You can have a describe block that describes all your tests, and you can actually put before each inside of this describe block so that all the tests before any of them are executed, executes before each. And then there's after all, which after all the tests are executed, it would execute after all. Yeah, let's keep on going. Let's see how to actually write a test, and then I'll do a demo. Now, when it comes to writing tests, what we're talking about is what's inside of this comment right here, right? How do we actually run a test and execute a test in Jest? One of the functions to pay attention to is you're going to see it everywhere is expect. And the expect function wraps the value you want to test against. Once you wrap that value with the expect function, you would use what we call matchers to validate and to run this assertion if the value is what you expect it to be. So here's an example of a test that we've defined. And right here, the result of this function, the sum, we're wrapping it with the expect function. And we're taking this to test against the expected result. And what happens here is the matcher. This is a matcher, so we're testing that the result of this is equal, it should be 2. So anything that you want to test against in Jest, you have to wrap it in the expect function. And this is the first part of it. The second part is the matchers. The matchers are incredibly important. The matchers is what you're actually doing to validate the result is what you expect it to be. So you're comparing the value that is outputted from the expect function with a matcher. And part of the journey in mastering Jest is just to see, well, what are the different types of matchers I can use? The most common one is to be, right? It's very common to use it to determine if what you expect and what the actual value is equal. So looking at the Jest website and documentation, and I also have this reference at the end of the slide. Here's a set of matchers that are available. This will get you 99% of the way there. Even to be, you can basically get 80% of the way there just by using to be. But here, I'm not going to go through each one of them. I'm going to skim through them alongside you here. We have to be, which compares for strict equality. We have to be null, to be undefined, or sorry, to be defined, to be truthy, falsy. JavaScript is pretty funky with truthy and falsy values. To be greater than, less than, and all these other things. You can actually even test if a function is throwing an exception, right? Sometimes you want a function to validate if the input is correct, and if it's not correct, you would expect the function to throw an exception, to throw an error. You can also test for that and validate that in Jest, which is great. And then here, this is really neat too. You can check if an object has a property. For this property, for this key, does it have this value? That's pretty neat. For to contain, you can check if an array contains a certain element. And then really the list goes on. This is not, this should be pretty descriptive. Hopefully it should help you write more legible tests. Okay, demo time. Now I've written this calculator app, put a lot of effort into it. So let's write some tests. There's two ways you can define tests in Jest. One is that you can have this underscore test folder, which I'm not going to do. You can put all your tests in that folder. Another thing you can do is just label your JavaScript class with the name tests. So what I'm going to do is I'm going to create calculator.service.test.js. This is a personal preference, and clearly I can't spell calculator. It's a personal preference. The benefit of this is that you can see the test side by side with the service. And what we're going to do here is we're just going to do unit testing here for this demo. All right, so the first thing I'm going to do is call the describe function, and I'll just call this testing calculator. And the second parameter is a function. I'm going to use a fat arrow function. I'll make this a little bit bigger. And anything inside here is going to contain our test. I'm going to write another function here. I love autocomplete. I'm going to test adding two numbers. And that's going to be my first test. And my second test is subtracting two numbers. Now, in order for me to test this, I need to have the calculator service available to me, and I need to initialize it. So what I'm going to do is I'm going to use before each to initialize the calculator service using new calculator service. I have to choose the calculator word, right? Okay. Calculator service. This is VS Code being my friendly sidekick here. It auto imported my calculator service, which is great. Now I need to access this object in these two different methods. So what I'll do is I'll create a variable here called calculator service. And I'll assign it equal to new calculator. This is typically a good practice to create a new instance of the object before every single test that you execute. That way you get a brand new fresh object. And you don't want a situation where this test changed the state of that object and your other test is testing an object with a different state than what it was initialized with. So typically it's good practice to recreate the object before each of the tests. This is how I'm doing it. And let's just keep it simple here. Let's do calculator service, add 2 and 5. We would expect the result of this to be 7. I'm going to wrap the result in the expect method. And I'm going to use 2b as the matcher, and I'll put in the value 7. And then for this one, 2 minus 5 is -3, so I'll put 2b -3. So that's really it. That's really just in its essence. You have the describe block grouping your list of tests. You have each individual test right here, and you have the expect that wraps around the value, and you would use a matcher, always use a matcher after the expect to validate if what you're getting, the actual result, is what your expected result. So again, if we break down our 3-step process with testing, step number 1 is setting the context. Step number 2 is performing the operation. And step number 3 is validating that the actual result and the expected result is the same. Now to execute the test, I'm going to use npx Jest. I need to run the Jest dependency that I've installed right here. And because I didn't install it globally, I need to use npx as a way to execute the local dependency. Of course, something failed. Let's see here. Oh, okay. I can say I did this on purpose, but I probably didn't. But this is good to see kind of error reporting. So here we can see that it executed the test really fast. This is really fast, 3 milliseconds. I don't think I've seen something this fast. It added 2 numbers that worked. Subtracting 2 numbers didn't work. And this is awesome because it tells us, okay, I'm expecting -3, but what I got is 7. -3 does not equal to 7. There's something wrong with this test. So this is a pretty nice reporting. It just is super fast. It did that all in less than 1 second. And this is just me being a bad developer. I've copy and pasted this, and I probably should change this to subtract. And now if we run the test again, awesome, both tests are passing. All right, so that's really the core essence of it. Any questions about this setup before we move on?
Is if you have like a lot of unit tests, like in this describe block, like is it better to like separate them out somehow, or is it okay to just have like the long list of them in one file?
Typically, what I would recommend in terms of organizing is that if you're doing unit tests, a describe block, it should be a 1-to-1 relationship. So every class that you're testing against, it should be one describe. And then each test can be a specific method on that.
Yeah.
But this becomes more of an art than a science. And then, as you go through it, you can talk with like a senior engineer or whatever makes the most sense in terms of legibility, really. You can group things. There's no hard and fast rules for how you group them. But one good practice is that there can be one describe block per class that you're testing and one test per method. So there's a good question by M. And the question is, why did I call it this? We can talk about this all day. I think I just borrowed from another framework I've been using recently, Nest.js, not Next.js, Nest.js. And then this is how they name their classes. I typically call service class basically a class that does a lot of business logic and processing. So I could probably call this calculator.js. But yeah, don't look at the name. I think this is just me borrowing from another framework. But this is the important. Cool. All right. Mocking. All right, so this is the next very important topic to cover. And in object-oriented programming, we have objects depending on each other, right? So it's a web of objects. And to do and to think about it, whenever you write a class, you have a lot of dependencies in that class. Your class can be directly connected to a database. It can be making HTTP requests. It could be saving to a local file system or accessing a local file system. It could be connecting to external systems and maybe even IoT devices and microcontrollers. So in order to do unit testing, you have to mock out these dependencies. And when we say mock, we really mean stub, and to not actually call these downstream services, but instead sort of put in a placeholder implementation and not call these downstream services. If you mock your dependencies that your object depends on, your test is going to execute faster because you're not going to have to wait for the database or the network request to come back, for example. Your tests are independent of the database or the network connections because you're mocking the dependencies. You don't pollute the downstream services with test dummy data. Maybe maybe from experience, somebody in the front end team has done that manually, but if you run a lot of tests, you end up creating a lot of dummy data, and then that can pollute the database, etc. But if you don't actually hit the downstream service, then you wouldn't pollute the database. So, and then, there's things that you think about if you're using third-party services like Google Maps, for example, they have rate limits. So they can only reasonably let you make so many API requests in a given second. If you're running an automated test, you're going to be running that script very frequently, and you don't want to blow up the API limit calls. Sometimes they will just stop you. Other times they might just charge your credit card more because you're just paying for how many times you call them. Now, what we can do in Jest is that we can mock functions. So instead of calling the actual implementation, we can mock the implementation and call the dummy implementation instead. Sometimes it's important to know that if we're actually calling the function, if it actually has been executed. So there's functions that allows us to determine whether or not we have called a specific function, how many times we have called a specific function. If we did we call it with some sort of arguments, which is very useful. So let me do a second demo time here, showcasing mocking. This one's a little bit more complicated. I might need to pull up my demo here. Okay. Now let's say I have a class here called user service.js. And the purpose of this class is to manage anything user related. For example, creating a user. And let's say we're expecting a set of parameters to create the user. Now for this service, we actually need to call API to create the user. So I'm gonna have a constructor here, and let's just say the parameter is user API, and we'll make this a property of the class. The create user method, let's just keep it simple. We're simply going to pass the information to the API. We call create user. Now, what I'm going to do for this test is I'm going to create a mock implementation of the user API. And one way I can do this is to add a folder here. This might work. I'm going to add a folder here called __mock. And I'm going to create a new file called user.api.js. And let's create the class called user API, create user method. So you would imagine that the create user method might do something like this. If we are mocking the implementation, we're not actually calling the API. We're just pretending that we're calling the API, and we're just returning the data that we're given. And let's export this. Now, what we want to know is if we call our user service, did we actually call the API? So we need some way for Jest to listen in or spy on the method. And to listen in for the method, instead of returning the method as is, we're going to call jest.fn to wrap around the actual method. This allows Jest to intercept the method and to keep track of whether or not we're calling the method. And just to make it a little bit more realistic, this method will be asynchronous because it's a network request. And we will also module exports this user service. All right. So now we have a user service that when we call create user is going to call the API to create the user. And let's write a test for it. user service.test.js. Again, the naming of it is these files, you can name whatever you want. It doesn't have an impact on the test. So let's describe the user service right here. And we want to test creating a user, not test washer. This actual operation is asynchronous. We're going to put an async keyword here. And we're going to have some sort of dummy email, test@test.com. Let's create the parameters here. And what we want to do is call user service create user params. In order for this line to work, we need to actually make sure we have an instance of user service that we can work with. Now let's take it a step back and define that to be a variable that is accessible to the rest of the test. And we'll have a before each method that will be executed before each test. And we will initialize a new user service. In order for this user service to work, we need to have a API. Because if we look at the constructor, it is expecting an API. Let's have user API right here. And set user API equal to new user API. We can just put user API here. And let's put this as the first argument to the constructor. Now we have a user service we can work with. Before every test, we make sure we initialize it. And now we can actually call the user service. Now, there's two things we can do a few tests here to make sure that this is working the way we expect. First thing is we can simply inspect that the email we get back is the same email that we pass. Let's actually test that really quick to see if it works. Okay. Let's see what's the issue here. Require cannot find module. Okay, I think I need to put the mock in the top level. Let me do that really quick. So API.js module exports. Interesting. Let's see. Pretty sure this is what I had. Oh, sorry, it's mocks with a S. Of course, it's these one character mistakes. All right, perfect. So that's good news. Now, what's more interesting for this test is that we want to know that the user service is actually calling the API and not simply returning the email for us. What we can do is we can expect the user API, the create method, create user method, to have been called. We can take it another level and to even check that the user API create user to have been called with params. We can actually check to see if did you actually call the API with these parameters. Not that you just have called them, but have you called them with the parameters? That is really cool because that means just by doing this mock function here, Jest is keeping track of if you actually have invoked it. And if you invoked it, what parameters do you invoke it with? So by doing this mock service, we're not actually calling the API. But when we're doing this test, we know that okay, we have the result that we expected, and we have actually called the method that supposedly will call the API. So here, that's an example of mocking a dependency where we don't actually call the downstream services, but we have a stub, and we would inspect if we have called the downstream services using Jest and the mocking capabilities. All right. And that is really the end-to-end demo of Jest. Here's a few helpful links for articles. I highly recommend everyone here read through them. But as we close this off, any questions on the demo or testing in general or Jest? All right, well, if not, thanks everybody for your time. This is a recorded lecture, so we can go back and see it. And yeah, that is all for today. Thanks everyone.
Thanks, Bennett.
Thank you.